Now we want to make sure you're really good at using inverse norm to find this lower bound or upper bound for some area under the curve. Now remember, what we're doing is backwards, or the inverse of what we were doing when we were using normal CDF. In other words, we were given the interval and we were going to find the area under the curve that corresponded with that. So this time they're going to give us the area and we're going to find the interval that corresponds with that area. So let's start with this one here. We're given the three things, and we have to be given these three things. We must know the population is normal. We need to know the value of the population mean, and we need to know the value of the population standard deviation. Now this is what they want us to find. Find this point on the number line, this upper bound for this interval, such that the area to the left of that upper bound is 0.25. This represents 25% of the population that is below this point. You can think of this as the first quartile or the 25th percentile. Those are terms we've already learned. So hopefully you haven't forgotten them. So keep reviewing, if that's happening to you. All right, so how do we find that point on the number line? Well, what you've got to remember is, what were you given? I was given the area under the curve. What are you being asked to find? The interval on the number line. And you must remember that you use inverse norm to find it. So let me turn my calculator on. I press the yellow second key and then the vars key. And what we want is choice number 3, inverse norm. So I'll press 3 to select that. Now it needs to know the area to the left of this point on the number line. Well, the area to the left is 0.25. You notice you always enter areas as a decimal. Then we press a comma. Then it needs to know the mean. Well, that's 125.63. Then we press the comma. Now it needs to know the population standard deviation. That's 7.8. Then a right parenthesis, hit enter. So this 120.37, rounding off, is this point on the number line. So over here, let's go ahead and say that the probability of our random variable x being less than this 120.37 is equal to 0.25. So make sure you're clear. The 120.37 is the point on the number line. This right here is the area under the curve. Very important you keep that all straight, because if you don't, you're going to be awful confused. All right, let's look at another one. Now in this case, we're looking at an area that's centered in the middle. This is the middle 85% of the population. We want to find the lower bound and the upper bound that contains this middle 85%. So I'm going to use the inverse norm twice. Once to find the lower bound, and again to find the upper bound. So let's start with the lower bound. So we're going to press the yellow second key, vars, and 3 for inverse norm. Now what's the area to the left of our lower bound? Well, the middle area is 85%. So that means the tails would have to add up to 15%. And those tails are equal to each other, so half of 15% is this 7.5%. See, it's very important you make this sketch, so when you enter in the area to the left, you don't mess up. So in this case, 0.075 is the area to the left of our lower bound. Then we enter the mean, 125.63, press the comma, then the standard deviation is 7.8. So that's our lower bound, 114.40. Now let's find this upper bound. So I press the yellow second key, then vars, 3 for inverse norm. Now what's the area to the left here? Well, we have a 0.85 here, that's the 85%, and then we've got this 7.5%. So what's 85% plus 7.5%? It's okay, you can do the addition on your calculator, but it's 0.925. In other words, 92.5%. And we press the comma. We enter the mean of 125.63, comma, then the standard deviation of 7.8, then a right parenthesis. Hit enter, and that's our upper bound. Right here is 136.86, rounding off. So let's type that in. So the probability that our random variable is between this lower bound of 114.40 and this upper bound of 136.86 is equal to this 85%. So I can write as 85% or as 0.85. Either is fine. Now, let's look at this notation you're going to be seeing a lot of in this class. And it looks like this. You'll have a Z here with a number as a subscript following it. So you see a Z here, and then followed by the subscript by some number. You need to remember that that number in the subscript is an area under the curve, and it's an area that's in the right tail. So we want to know the point on the number line that's under the Z curve, which is the standard normal distribution where the mean is 0, standard deviation equals 1. So what's the point on this number line such that the area to the right of it is this 0.10 or 10%? So your first goal is to understand this notation, what it's telling you. Once you've got that, then you probably would realize that, oh, I've got to use inverse norm to find that. So let's get under here. And so I'm going to press the yellow second key and then vars, 3 for inverse norm. Now what's the area to the left? See, it gave me the area to the right. So if the area to the right is 10% or 0.1, the area to the left must be 90% or 0.9. So I'll enter 0.9, comma. Now this is the Z distribution, so hopefully you remember the mean is 0, the standard deviation is 1. Now hit the right parenthesis, hit enter, and so this point on the number line is 1.28. Remember Z-scores, what are they? You know, that basically tells me if I go 1.28 standard deviations above the mean, then the area to the right of it is 10%. 10% of the population is 1.28 standard deviations above the mean. So whenever you find these answers, put the answer in words to reinforce what you found out. Well, that's enough to keep you busy for this video, but you keep practicing using inverse norm and normal CDF and make sure you're not getting those two confused with each other.